Okay, hello and welcome to our third webinar of the day. Our topic today is the NPD closure project, changes to the EIS resulting from feedback. My name is Mike Giardini. I'm a communications officer with CNL Stakeholder Relations team. I will be the host. So before we get started, a few items. CRL is located on the unceded and unsurrendered territory of the Algonquin Anishinaabe people. As an organization, CNL recognizes and appreciates their connection to this place. CNL also recognizes the contributions that First Nations, Métis, Inuit, and other Indigenous peoples have made, both in shaping and strengthening this community in particular, and this province and country as a whole. So the way this webinar will work is we will start with a presentation by the subject matter experts. Then we'll open the floor for Q&A discussion period. So all the Q&As have to be written, and we will get to them. You can type in your question at any time, and then we will take them up at the end. There is simultaneous interpretation. So if you would like to hear it in French, there is a globe icon on the bottom right on the bar on Zoom. Click that and you will hear French, the French language. So we have this planned for about 1 hour. What else are you gonna do today? Because it's snowing, we have a blizzard where we are in Deep River. We anticipate that it'll be about 30 minutes for the presentation, and the rest will be open for questions. We will be recording this session. So because we like to post it on our YouTube page, so just to let you know. And if you're having any technical difficulties or you'd like to get in touch with us in any way, ermstakeholder@cnl.ca is the best to do that. Now I'll introduce our panelists. Presenting today are Katie Shorter, Manager of Regulatory Approvals for the NPD project, and Courtney Power, a Decommissioning Environmental Specialist. So I will hand it off to Katie.
Good morning, everybody. Thanks, Mike, for the introductions. So we're continuing our work on the NPD closure project environmental assessment and license change with the CNSC. And today we wanted to highlight some of the changes we've made so far based on feedback we've received from stakeholders, the regulator, and Indigenous peoples. We're looking forward to taking this time to demonstrate that we've considered all feedback and comments, and we've adapted, changed, and modified aspects of our project based on what's important to you in order to build a strong community-informed closure project. So this slide just really runs through all the webinars we've done to date on NPD, stretching back to 2018. The focus of these webinars has been on the topics of most interest to stakeholders and Indigenous people. We've also conducted virtual and in-person open houses across Renfrew County, the Ontario side, and also in Quebec. We've had public information sessions, site visits, presentations, meetings, and other community events as well. From these engagement activities, we've heard feedback on the topics of most importance to the public, stakeholders, and Indigenous people, and we continue our work to support meaningful participation of all of those groups in the EA process. As part of that, we've received hundreds of technical questions from Indigenous groups and members of the public, regulators, government officials, and key stakeholders, and we've been responding to those questions and updating our environmental impact statement to address those concerns. So just a quick overview of what we'll cover today. We're going to give you a bit of an update on the status and progress of the NPD closure project. We'll highlight what we've heard and what we've changed, and then review what's next, and then an opportunity for questions at the end. So before we dive into some of the feedback we've heard, I just want to give you an update on the project timeline. So the red or the hot colors on the left side of the screen, that's where we've been focusing our attention so far. We've received lots of comments, and we're continuing to address those comments and prepare supplemental studies that have been requested. Our next step is to submit a revised draft EIS, and we expect to do that in July of 2023. We've taken into consideration the feedback that came as part of the NSDF hearing and also the procedural direction that was issued following the hearing. And we're taking time to collaborate with several First Nations and the MNO to revise, update, and integrate their interests and concerns and their Indigenous knowledge before we submit our next revision of the EIS. The rest of this regulatory process, you guys have seen many times if you've joined our webinars. So the revised EIS goes in, the CNSC and the federal, provincial, and Indigenous review team has another opportunity to review what CNL has put forward. We expect to receive additional comments as part of that review process, and we'll need to respond to those comments before we submit our final EIS, which we expect to do in the summer of 2024. After that point, the cool colors on the right side of this graph, the blues and the greens, that is where we move into the commission hearing itself. It's two-part, similar to NSDF. There will be another opportunity for public and Indigenous input. There's an intervention period before the Part 2 hearing. The dates for all of those things are still to be determined, and that comes out of the timing for CNL to submit its final EIS and for the CNSC to accept it as complete before they schedule the hearing dates. Now, I think we're ready to jump into some of the topics that we've heard. So first topic today is inventory. So CNL has heard that the public, stakeholders, and Indigenous peoples are interested in more information about the radiological content or the inventory of the proposed NPD disposal facility. So following the submission of our 2017 draft EIS, CNL undertook additional neutron flux modeling using modern 3D codes and libraries and combined that with physical sampling to ensure that the inventory of the reactor was appropriately accounted for. We also completed a full building characterization, including the nuclear systems, to verify the total radiological inventory. The reactor vessel itself contains most of the remaining radiological inventory, although as we've noted in our previous presentations, all the fuel was removed in 1988. So using this modeling information and our physical samples, we're able to build a reference inventory that we use in our calculations, that we also apply a level of conservatism and uncertainty to ensure that we adequately account for all the inventory in the facility. One of the other updates that's happened is the management of PCB waste. The PCB waste will all be removed from this facility prior to decommissioning, and in fact, some of that work is already underway. Also, compared to our original environmental impact statement, we have updated our calculations and the total quantity of lead that is assigned inside the facility. And probably one of the most important things was to look at the waste material itself. As I noted, a lot of the inventory is contained within the reactor vessel itself and the other metal reactor components. So in order for that contamination to be released, those metals need to corrode. CNL has looked in detail at each of those metals and evaluated through literature study the range of corrosion rates. And by doing that, we can understand and make sure that the rates that we use in our long-term safety assessment are conservative. Next topic area where we've heard feedback is related to the design of the project components. And when I say project components here, I would point to the grout that's used, the engineered barrier that's going to go over the top of the facility once the grouting is complete. And so based on that feedback, CNL's expanded the detail that we've included directly in the EIS. That's section 4.3 of the EIS, where we walk through each of the project components. We've also done detailed design for that engineered barrier to ensure that it's the right size and that it has appropriate seismic resistance. As part of that design work and as a part of identifying materials to use in both the grout production and the construction of the engineered barrier, we've looked to ensure we can identify materials that are local to be used in those construction activities. Next topic is the grout itself. There's interest, we've heard interest about the grout formulation that we're going to use. So we're going to use a custom grout to help contain and isolate contaminants, ensure stability of the facility, and to reduce corrosion of the reactor components. That grout is a mixture of a 90-10 mixture of ground blast furnace slag and Portland cement. There's also sand, water, and admixtures to make sure we get the right fresh and cured properties so that the grout flows where we need it to flow as it's filling the facility, and that it sets up and has the right sort of strength and hydraulic conductivity once it's cured. The other area of interest related to grout is where we were going to construct the batch mixing plant, the on-site batch mixing plant for grout. That facility is going to be located on the footprint of the former training center, so nearby to where the existing facility structure is. And the other thing that's happened since we developed the original plan is that we've done testing of the grout to make sure that the locally sourced materials will work and that the grout formula can meet the fresh and cured properties, as I've noted. That's to make sure it can flow around pipe and tanks and that it sets up the way that we want it to. The other area we've heard feedback is everyone, including ourselves, we need to have confidence in the long-term safety performance. We've also heard some concerns about the impacts from events in the natural environment, such as earthquakes. So as part of CNL's long-term safety assessment, we look at how the facility will evolve over time, how it might degrade, how the different components might break down. And then we look at how receptors, so people and animals, might interact with the environment surrounding the facility. So we look at how that might happen normally. So climate change, an earthquake happening at a certain frequency of a certain size, the concrete and the grout eventually breaking down. So that's called our normal evolution. So it's the expected way that the facility will perform out into the future. But we also look at a number of disruptive events, both natural disruptive events like significant earthquakes, but also events where humans interact with the facility, excavate into it, or drill a groundwater well. So as part of that long-term safety assessment, CNL assumes that a 1 in 10,000 year return frequency earthquake occurs at 1,000 years. And this results in cracking of the facility, mostly above the bedrock. We also consider as a disruptive event a more significant earthquake, one that might happen on the frequency of 1 in 50,000 years. And this causes more significant degradation of the concrete structure and the grout. The other thing to think about is the long timescales that we're looking at. And so one of the ways we do that is consider natural analogs. So things that happen in the real environment over long timescales to see how the iron-based materials, the lead, the concrete, and grout will behave. So our environmental impact statement has a detailed section that runs through the natural analogs that we've looked at. Essentially, that information supports the corrosion rates, the degradation rates, the performance that we model in our long-term safety assessment. The other thing that has been updated in our long-term safety assessment is that we've added additional receptors since the original assessment was completed, and those receptors include a hunter or a recreational user, an off-site cottager, and an Indigenous group. And again, as part of that assessment, we look specifically at how those individuals or those groups might interact with the environment around the facility. Next up, we've also heard concerns from the public and stakeholders, also and Indigenous people, that our proposed project does not align with the International Atomic Energy Agency's safety standard for decommissioning. CNL believes that it is following the safety standard for decommissioning, but more importantly, we're focused on the safety standard for waste disposal, since the facility in its end state is going to be classified as a disposal site. The International Atomic Energy Agency's safety standard states that in situ disposal is not a suitable option for all nuclear facilities and should be considered only under certain conditions. CNL agrees with that not all nuclear facilities are suited for in situ disposal. But NPD has some unique characteristics which make it suitable for this type of long-term disposal. One of those being its location almost 80 feet below grade in the bedrock. It is also important to note that NPD qualifies as a legacy facility under the Canadian standards and regulations. And the facility has characteristics, and also the site that has characteristics that support in situ disposal strategy. One of the other bits of information that CNL has prepared is a summary of industry examples of in situ disposal being used around the world, both in a nuclear context, but also in Canada for disposal of other hazardous wastes. That is it for me today. I'm going to pass you off to Courtney, and she's going to run through a few more areas of feedback we've received and what we've done to address those.
Thank you very much, Katie. So the next topic that we've received interest on is site characterization, so geology and hydrogeology. The feedback that CNL has heard is that the public, stakeholders, and Indigenous peoples want soil and groundwater quality and groundwater flow to be maintained, and they want confidence that CNL understands the geology of the site. So based on the feedback that we received, CNL has included additional valued components, which includes soil quality, groundwater, and groundwater flow, which provides the pathway to biota. New information was also added on local soil quality, including chemical contaminants. Information was added on hydrogeological conditions and properties. This included an expanded and improved description of the site and regional geology. Regional groundwater information included local well information from Ontario's Ministry of the Environment and Climate Change, and recent groundwater sampling data was also added. CNL completed a phase 2 environmental site assessment. So this additional characterization has allowed us to improve our description of the geological and hydrogeological environment. CNL has also undertaken a target geoscientific characterization program and has updated the geosynthesis report, which is a key technical supporting document to the EIS. A couple of improvements are a better description of intact rock and rock mass quality at the site, and the improved geosynthesis report also includes new information about neotectonics and paleoseismology. And for those of you who would like more information on what these terms mean, so neotectonics are motions and deformations of the Earth's crust that are current or recent in geological time. And paleoseismology is the study of geologic sediments and rocks or signs of ancient earthquakes. Next slide, please. So the next topic is the protection of the Ottawa River. CNL has heard from the public, stakeholders, and Indigenous peoples that they want to make sure the Ottawa River is protected. Protecting the Ottawa River is extremely important to us. So based on the interest and feedback that we've received, CNL has expanded its list of mitigations for the protection of the Ottawa, or protection of surface water, including the Kitchissippi, within the environmental impact statement. These include in-design mitigation measures, dust suppression, runoff diversion, and washout pit design and management. CNL's modeling also shows that radioactive inventory will be contained and will remain isolated from the environment. So this includes undertaking a thorough, detailed modeling of potential releases after the proposed closure to understand how the plan could affect the Ottawa River. The scientific analysis demonstrates that the NPD closure project will protect the river with no negative impacts. The final grout design, a comprehensive study of the geology of the site, and a detailed earthquake assessment all contributed to this finding. CNL will also continue to have extensive monitoring systems in place and mitigation strategies for worst case scenarios to make sure that the Ottawa River remains protected no matter what. Our modeling shows that the radioactive inventory will be contained and will remain isolated from the environment. The radioactive inventory will remain contained because the majority of the radioactivity is embedded in the reactor system's metals, which take a very long time to corrode. Also, the thick underground concrete walls of the structure provide barriers that slow the movement of contaminants. The grout will create an alkaline environment, which limits the solubility of many of the contaminants. In situ disposal will isolate the reactor systems and facility structure. And by filling much of the facility with grout, CNL is further strengthening the natural isolation provided by the bedrock and ensuring protection from the environment, protection from environmental processes such as climate change. CNL has and will continue to conduct regular monitoring of the NPD site. The monitoring results continue to demonstrate safe performance and continued environmental protection. Monitoring will continue after the site's closure, and monitoring results will be posted on CNL's website. Now, a key aspect of the follow-up monitoring program is to ensure that the facility is performing as expected and that the contaminants are contained. Next slide. Okay, so the next topic is species at risk, which includes biodiversity and habitat protection as well. So the feedback that CNL has heard from the public, stakeholders, and Indigenous peoples is that they're interested in the biodiversity at the NPD site and how CNL will protect habitat and species at risk. So based on this feedback, CNL continues to undertake regular biodiversity surveys, which include surveys for shoreline birds, waterfowl, songbirds, and others. Routine bat surveys are also completed within the crawl space of the facility. CNL has also updated its environmental impact statement with the most recent species at risk listings. So for example, the monarch butterfly is now assessed as endangered by the Committee on the Status of Endangered Wildlife in Canada. CNL has also included additional mitigation measures related to migratory birds and avian and hepterofauna species at risk. CNL has consulted with subject matter experts from a variety of different industries to protect chimney swifts during project activities using best practices, mitigation measures, and how to monitor the impacts to these birds. For chimney swifts, the original decommissioning design included building an alternative habitat and demolition of the existing ventilation stack at NPD. In order to minimize the risk to the chimney swifts, CNL actually decided to retain the existing stack, and instead of demolishing it, instead of demolishing it and replacing it with a new alternative habitat. So this decision was made with input from a panel of experts composed of academia, government agencies, and non-governmental organizations. Since their current roofs will be retained, the project predicts the effects will be minimal given project activities will occur during daylight hours when chimney swifts are out foraging. CNL has also included mitigations to protect important species at risk, for example, milkweed. So milkweed is an important habitat for the monarch butterfly, which is a species at risk. NPD undertakes activities such as sweeping of work areas, avoiding vegetation removal during periods of monarch butterfly presence, and reseeding areas with milkweed. CNL considers both habitat and exposure-related effects within its environmental assessment and has updated its ecological risk assessment technical supporting document, which includes a clear description of the methods used. The EcoRA continues to predict no undue effects to biota. Go to the next slide. The next topic focuses on Indigenous values and knowledge. So as part of our corporate, environmental, and social responsibility, CNL recognizes the importance of meaningful engagement to build strong working relationships with First Nations and Métis communities. The feedback that CNL has heard is that Indigenous peoples want to ensure that they've been engaged and that Indigenous values and knowledge are incorporated into CNL's assessment. So based on this feedback, CNL has continued its efforts to establish relationships with Indigenous communities and organizations through the means that Indigenous peoples would like to be engaged. CNL has supported several Indigenous-led knowledge studies and has integrated the findings into the environmental impact statement. So for example, content from a large Algonquin knowledge and land use study report, as well as harvest and diet, traditional use, and culture and rights studies have been added to enhance the environmental impact statement. CNL has expanded its description and assessment of traditional use to ensure that Indigenous traditional knowledge has been appropriately integrated, and this is important in CNL's consideration of potential effects. We've also added value components based on feedback, so traditional land and resource use, value components. So for example, these include moose, berries, and mushrooms. So the environmental impact statement update includes an additional list on the engagement process and how Indigenous interests have been incorporated into the value components selected for the project. We have also included a specific Indigenous receptor to the human health assessment in NPD's post-closure safety assessment technical supporting document, as well as the environmental impact statement. So the self-sufficient Indigenous receptor uses parameters that match pre-European contact to allow for conservative estimations. The specific information from the harvest and diet study has also been used in CNL's assessment to confirm that the parameters used are appropriate. We have also invited several local Indigenous communities to the NPD site to complete their own biodiversity inventories. And with these actions, we hope to instill confidence in the long-term safety performance at NPD. Therefore, CNL will involve Indigenous communities and organizations in monitoring activities that will confirm the conclusions of the environmental impact statement and provide that reassurance that mitigation measures are effective. CNL is also developing an Indigenous-driven risk-informed communications program for the NPD site to promote an understanding of the EIS results and to help alleviate any concerns that communities may have. Next slide. Okay, so the next topic is follow-up monitoring. So CNL has heard that follow-up monitoring at the NPD site is a topic of interest and importance to stakeholders, the public, and Indigenous peoples. Follow-up monitoring is an important part of the project to demonstrate that the proposed grouted facility is performing as expected. This monitoring starts now, so before project approval, and continues throughout the two main phases of the project, which is the decommissioning execution phase and the institutional controls phase. Based on the feedback that we received, we have developed and shared 3 draft follow-up monitoring plans. So this includes the environmental, effluent, and groundwater follow-up monitoring plans. We've conducted public and Indigenous workshops in 2019 and 2022 on these plans, and we continue to incorporate written comments as they come in on the plans. So these 3 documents are considered in draft until the CNSC makes their environmental assessment decision for the project. CNL has also shared draft plans through a variety of different means and sought feedback from the public, stakeholders, and Indigenous peoples. This includes working with Indigenous communities and organizations to incorporate traditional knowledge and monitoring of key valued components into the project. The key revisions include adding sediment monitoring to the CNL's routine monitoring the effectiveness of mitigation measures, so for example, species at risk, and groundwater monitoring at any spring that may arise along the slope. Baseline sampling also includes sediment and benthic sampling, fish habitat surveys, and noise monitoring. So the decommissioning execution phase is a 2-year period of active decommissioning activities, which include demolition and grouting activities. The proposed follow-up monitoring during this period will include emission and effluent monitoring, as well as regular chimney swift counts during their seasonal presence at NPD. Monitoring will continue before we get project approval to get an idea of the current baseline for environmental conditions. So once the project gets going, we'll continue to monitor so that we can compare the results back to the baseline conditions to see if and how the results are changing. Follow-up monitoring through active monitoring and surveillance will continue through the in-situ control phase, which is a minimum of 100 years after the facility is grouted. Specifically, this will include visual inspections and monitoring at the groundwater for parameters that would trigger the need for additional investigation and potential mitigation actions. Okay, so this slide references environmental impact statement sections and technical supporting documents. So basically gives details on where to obtain specific information within the environmental impact statement itself and other technical supporting documents. And this list gives a variety of all the different topics that we've discussed in this presentation today and where you can find details on each one. And that concludes the presentation slides. So I'll turn it back over to Mike now for any questions.
Okay, thank you, Courtney, and thank you, Katie, for that great presentation. Lots of information in a short amount of time, but we will now get to questions that have come in, and there are a few, so we'll get started right away. First one is, you say you expect additional comments when you release a new draft EIS in July 2023. Will the draft be made public, and do you expect the public to comment?
I can take that one. Thanks very much for your question. So the revised draft that we will submit to the CNSC in July 2023, once the CNSC accepts that revised draft, we will be sharing that with the public. We'll post a link and send out an email blast to stakeholders, et cetera, to let them know that we've made it, first of all, to the next step in the process. the regulatory process, but also provide a link to the revised EIS. We welcome comments from the public and stakeholders at any time. Those can come to ermstakeholder@cnl.ca. I think I got that email right. And there will be another formal period for comment as part of the regulatory process, and that is at the stage of the interventions, which come before the Part 2 hearing.
Thank you. Next question is, what is the local source of blast furnace slag? That one go to Graham? Yeah, he's just getting his camera on. Just one sec.
Hi, good morning, everyone. Not sure you can see me. It looks like I'm the invisible man on my end. I believe at the moment we haven't actually selected a supplier locally, and that's something that we would work on when we are further along in the project and we're able to actually go out for bids and ask for people to bid on supplying that material. But I can say that the majority of blast furnace slag actually comes from Ontario. I believe it's a byproduct of the steel industry, and 80% of steel manufactured in Canada actually comes from Ontario. So that's as far as I could go, and Ontario's as local as I can actually specify at the moment. So I have to apologise for not being able to provide any specifics for that one. Okay, thank you.
Thanks, Invisible Man. Thanks, Graham. The next question is, could you please list the characteristics that support in situ disposal facility with specifics?
I can take that again. There are quite a number of characteristics associated with the disposal facility when we actually get it constructed and built. Those all provide a number of barriers to act to isolate and contain the waste deep into the disposal facility. Sorry. There's a list of these things. How we have like the engineered cover that we will be constructing, and that will slow resaturation of the facility, preventing surface water entering into the facility and flushing, treating out before it can decay. We have other things like characteristics of the waste there. It's very low waste inventory. The bulk of that is actually contained within a corrosion-resistant metal matrix. That will help to, again, contain the material within the facility and stop it releasing too fast before it has a chance to decay. Another characteristic is we have a large portion of the facility is below grade in bedrock, and that provides a robust shielded underground structure. It's protected from the environment and also from human intrusion. Another advantage of being buried in the bedrock is it's got such a low permeability, so it's water only flows very slowly through it. That means it's very difficult for the water to flush out any of the contaminants that are stored in the facility there. Associated with that, the majority of contamination is in the reactor vault, and that's buried deep within the facility, and that's well underground, deep into the bedrock. The structure is also constructed of strong reinforced concrete, and that will be backfilled with grout, which again will prevent subsidence. And the grout also provides a number of chemical properties to prevent the waste being flushed out. So things like it will absorb the contaminants that they get onto it, so it physically holds them like a sponge. I think other characteristics we have. Again, I mentioned the reactor vessel steels and zircaloy. They corrode very slowly in the alkaline environment that's provided by the concrete and grout there. And other things as well is that we'll maintain control of the site for quite a long time under institutional control. So that'll prevent anyone using the site for other activities for which we'd rather stop them from being able to access any of the waste. And that's probably enough barriers and things in place, I think, for us to answer that one. Okay, Mike.
Yeah, thank you, Graham. We'll go on to the next question. It was my understanding that CNL was applying to build a batch plant outside the gates in Chalk River along Plant Road. Has this application been withdrawn? I believe Katie will take that one.
Yeah, thanks very much for your question. So I do not believe we ever made an application to construct that batch plant outside of the NPD site. There was, at the beginning of the project, a plan to not have a dedicated batch plant facility, but to truck in the grout from an existing facility. That causes challenges with the grout getting to the facility on time. That puts extra trucks on the highway. And so very quickly we transitioned to planning to have that batch plant located at NPD. And the most recent sort of evolution there is deciding exactly where we want to put that batch plant. There was several locations considered.
Okay, thank you, Katie. The next question is, where was the NPD fuel removed to in 1988?
Thanks again for that question. Great question. So we didn't talk a lot about it today, but initial decommissioning activities happened in the 1980s when the reactor was initially shut down. And those were maybe three main things. The first one was that the fuel was removed, and that fuel was transported to the Chalk River site, and it is in modern above ground monitored storage at Chalk River. The other thing was the heavy water was drained. It's also transferred to Chalk River for storage. And then the third aspect of the initial decommissioning was the removal of the non-nuclear portions of the generating station, so the turbine and other things, and also the former training center.
Okay, thank you, Katie. We'll move along here. The next question is, what specifically are the additional mitigation efforts to protect the Ottawa River?
I can take that one too. So Graham talked already about the different barriers that we have in place to contain and isolate the waste, the engineered cover that will slow infiltration, the grout itself, which has a pH that helps to slow corrosion, the fact that the contaminants are locked within the structure of the metal components and can only be released when those metals corrode. The other mitigations that we have in place really focus on the decommissioning execution phase for the project. So these are things like ensuring that we have covers over any stockpiles of materials for the batch plant to ensure those aren't being washed away as part in any storm events. We also will have a washout pit that is part of the batch mixing plant where we'll contain any liquids. Those liquids would be handled following our normal procedures for environmental protection procedures. So that liquid gets sampled and we have to disposition it through an appropriate route. We'll want to maintain existing vegetation where it's feasible. And we will divert water around exposed areas and stockpiles so to ensure that that storm water isn't interacting with the material that we have on site. So the EIS, or our environmental impact statement, has a whole section that runs through proposed mitigation measures that we will use to ensure we are protecting the surface water environment. And the main component of that is the Ottawa River.
Okay, great. Thank you, Katie. The next question is, you now plan to monitor any spring that may arise along the slope. Are there any springs along the slope at present, and what might cause a spring to arise?
I will take that one too. Lots of fantastic questions today. So right now there is a tile drain system that runs around the outside of the NPD facility. It intercepts groundwater before it has time to contact the facility. But what it also does is lowers the water table around the facility. So over time, that system will degrade, the groundwater table will rise a little bit, the facility will resaturate. And it's known from the historic information that before construction of the NPD site, there used to be springs on the hillside between the facility and the Ottawa River. So this is acknowledgement that as time goes by and the conditions return to, the groundwater conditions return to a more natural state, unaffected by diversion that is in place right now for the existing facility, those springs may reoccur on the slope between the facility and the Ottawa River. Thanks, Mike. I can take another question.
Okay. If the CNSC approves of the final EIS, do you approximately know when we can expect construction to begin?
That is another great question. So we didn't talk too much about the timing for how everything else plays out once CNL submits a final EIS. But I can provide an update about when we expect these things to occur. So if we submit a final EIS and it's accepted in the summer of 2024, that would mean that the hearings would take place in 2025 and CNL would could receive approval to proceed with the decommissioning work in early 2026. So that would be when decommissioning would begin. The physical decommissioning works are expected to last approximately 1.5 to 2 years. So decommissioning execution will be complete in 2028. These are the projected dates at this time, not set in stone and subject to CNL being successful as it moves through the regulatory process.
Okay, thank you, Katie. There is a question about that. Is AECL prepared to maintain institutional controls in perpetuity as per US DOE guidance on in situ disposal? Now, I can say that we can't speak for AECL. This has to come from someone at AECL, an answer, so we can reach out to them and get some written answer from them. Katie, if you want to add anything on that.
Yep, I'll jump in. So AECL has already made a commitment to maintain institutional controls for the institutional control period, which is a minimum of 100 years, but as long as necessary and possible. So although we CNL cannot speak for AECL, and I agree, Mike and the team can reach out and we can get a formal response from AECL on this topic. There has already been commitment, and AECL as the landowner and the owner of the liabilities has responsibility for these actions.
Okay, thank you, Katie. And just for information, if you're not from this area or just new to nuclear discussion, AECL is Atomic Energy of Canada Limited. And we are Canadian Nuclear Laboratories, the client for AECL. There is one other question that talks about radioactivity and isotopes, and that's too long-winded of an answer live, so we will go back and we will write an answer for the question that was asked, as well as any other questions that come in that we don't get to answer. When we send the link of the YouTube of the webinar, we will answer all the questions that we didn't get to. So we're not ignoring you. We're just taking our time to answer some of the questions. Other than that, that seems to be the end of incoming questions. Oh, there is one more. We'll take one more. How about that? We got 10 minutes left, so one more. So to end it, how far ahead in this regulatory process as compared to the WR1 process at White Shell?
I can take that one. Thanks, great question, especially for those of you who are following both projects. So for anyone who isn't aware, CNL is also proposing to decommission the WR1 reactor at Whiteshell by in situ disposal. For a period of time, NPD was ahead on the regulatory process, but just recently, before Christmas, WR1 submitted their revised draft EIS to the CNSC and it was accepted. So they are now in the process of that federal, provincial, and Indigenous review team review period, which is expected to last between 60 and 90 days. So they are just a little bit ahead. As I mentioned at the start of the presentation, the NPD team is going to submit the revised draft EIS for that project at sometime in July. And then should we be successful and that package passes the CNSC's initial completeness check, we would move to that federal, provincial, Indigenous review as well. So timing wise, then I guess I would say WR1 is maybe 6 months ahead of NPD overall.
Okay, thank you, Katie. And that will be the last one. I'll take this one. Can you provide the answer on the isotopes to all attendees? Yes. So when we send out a link to the webinar, it's to everybody that is on the attendee list. So we will provide answers to everybody for the questions that we can't get to. So that will end our webinar today. So thank you for attending. Thank you, Katie and Courtney, and everybody behind the scenes who helped make these webinars go today. So yeah, we will, once we get the recordings, we will post to YouTube both the English and the French translation. If you would like a copy of the presentation, please email us at ermstakeholder@cnl.ca. And we will send out answers to the questions to everybody. Thank you to Global for translating this webinar for us today. And if you are in Renfrew County, please stay safe. It seems to be a blizzard out there. Once again, thank you for attending, and we'll see you next time. Goodbye.